So good morning, everyone. Welcome to the second day of the Summer Hackfest. The program is a little bit changed. We need to recover the delay we had yesterday. So today the first presentation is actually the last of the first day, and Antonio Calanducci will talk us about the GLibrary 2.0 REST platform. So today we are going to have data management, workflow, and big data analytics platforms. Okay, so Tony.
Thank you, and good morning. My name is Antonio Calanducci. I work at INFN in Catania and also at the University of Catania, and I'm a freelancer software engineer. In this presentation, I'm going to present a platform we call GLibrary that we've been working on since 2007. Actually, the topic of today's presentation is GLibrary 2.0. It's a brand new release that has been developed starting this March, and it go out in beta in the last 2 months. So I'd like to present the feature of the platform. We will introduce the terminology that we use, the lingo, the GLibrary lingo. We will talk about authentication, authorization, how to deploy GLibrary services on your own infrastructure, even if you can use GLibrary server installed in our site. Then we will see a little bit about how we built GLibrary, what technology we used under the hood to create the services. A little bit of history, talking about GLibrary 1.0 versus GLibrary 2.0. They are quite different. It's an evolution. And at the end, I will try to run a live demo. So we're going to see together how GLibrary works and how can it be used for several use cases. So what is GLibrary? Probably during the last day, you have seen that we have a common partner that we are using for developing our system, REST API. So GLibrary is a platform to build REST APIs over datasets. Datasets that can be already existing, so already existing data collection, or it's able to create new data collection. It actually exposes REST APIs over data collection and using JSON format. I'd like to say GLibrary can be used also to restify a database. So you have a database deployed somewhere, you have a local database, you have a remote database. Through GLibrary, you can expose the tables of your database through REST APIs. We can use both relational and non-relational database. So this means if you have a MySQL database, a Postgres database, Oracle database, you can easily expose your tables and your relations through those REST APIs. But it works also for schemaless database, non-relational database that are very common those days, like MongoDB, CouchDB, DynamoDB, and so on. GLibrary itself provides APIs to interact with the service. So you use the GLibrary REST API to create REST APIs over databases, datasets. So we say that GLibrary provides REST API to create REST API. So that's what we say. Now let me introduce the lingo, the terminology that we use when talking about GLibrary. So the first one is the repository, is the main concept. So each instance of a GLibrary server can serve one or more repositories. You can think a repository is like a project or like a big database. So generally, when a user creates an account on the GLibrary server, the administrator will assign a repository to that user. And the user is able to work on the repository, controlling the repository. It's the owner of the repository. The second thing that we have in the library is the collection. This collection is a set of documents or records. It's similar to a table if we want to do a comparison to the database relational world, or just a MongoDB collection to make an example. A collection is actually a set of documents in JSON format. Then we have the item. The item is the single record, is the single document. It's a key value pairs in JSON format. Then we have an extra features that is the replica or attachment. For each item, for each record of our datasets, we can attach some objects, digital objects, some files, some JPEG, some PDF. And so, for example, our item can be some metadata that describe this object. And GLibrary provides API to upload and download the digital objects attached to each item through REST API. And the destination storages will be cloud storages or grid storages. And the user won't see anything of this. It's totally transparent. It has not to deal with authentication and authorization of storages. It needs just to deal with REST APIs and using the authentication and authorization system of GLibrary. Let's make some example of the topics we have just seen. So for example, we can have a repository for Sci-GaIA project, or a new project that we call My New Project, or the University of Catania can have its own repository, or we can have a demo project. We are going to create live, during the hands-on part, a demo repository. As collections, so we can think any kind of sets that have some common commonalities between them, like passions or activities, presentations, manuscripts, music, videos, and so on. So you're going to see here how this maps the structure of our REST API. So the endpoint will be v2/repos. Under repos, you have all the repositories, so like my project, VCT, and so on. And then you have the collection. So we really follow the REST principles, where we use path to reach resources. The item is a single record, like a song, like a job, like a voice, and generally it's identified by an ID. So this REST API indicates the 32 item of the music collection into the demo repository. Very simple. Finally, some items can have also replicas or attachment. So, for example, you have a PDF file, digital objects of an invoice, or MP3 files of a song. This can be stored and accessed through GLibrary REST APIs, accessing first the item. So the item 100432, using the _replicas path and the ID of the replicas. We call replicas, we can have several copies of the same files distributed, for example, in cloud storages and grid storages. So we really follow REST principles. So when we need to access GLibrary resources like collection, like items, like replicas, we use the HTTP verbs. So we use get, post, put, and delete for the CRUD operation. Post creates something new, like create a new repository, a new collection, a new item, a new replica. Put is for editing, for updating, so for collection, for replicas. Delete, same thing, allows to delete something like repositories, collection, items. And get, it's needed to retrieve, to get metadata, to get replicas, to get files. So once you understand the three concepts of GLibrary and you are able to use HTTP verbs, you will be really at home using these APIs. So now that we have seen an introduction of the GLibrary platform, let me illustrate some of the features that offer the actual system. So we can create local datasets on the GLibrary server itself. We're going to see in a minute that GLibrary provides a server on site or on remote server. So you can use GLibrary to access databases that are not locally. We support both schemaless and fixed schema collection. And we can also create a new collection with data coming from collection database stored in remotely. We support relations. If, for example, you have a products in collection and invoices collection, you can create a REST API structure that gives you all the invoices where a given product has been used. We see that we implemented a powerful query syntax in the URL. So if you want to filter, you query your collections, you can use operator like limit, skip, where, like, with logical operator, regular expression, comparison, ordering, just in the single URL. So you have a complete language in URL to make queries to your collections. We have, of course, permissions. We can set access control list on our repository and on our collection. And finally, for the storage capability, you can both store files on grid. We support at the moment the disk pool manager, but it's quite easy to add other plugin to support other kind of storage, like the local storage or FTP. And the cloud storage, at the moment, we use the OpenStack Swift because that's what we have at the Fed Cloud infrastructure and in our local infrastructure here. So, as you have thought, GLibrary is the central point of our architecture. So we have a central server where the GLibrary code runs that orchestrates the connection with storages and with databases. So GLibrary exposes, as you have probably understand now, REST APIs to your clients. So if you have browser clients, if you have mobile clients, but even if you have desktop clients, every client now can use REST APIs. So the GLibrary service will provide access to remote database. As we have said, we support MySQL, Postgres, MongoDB, that, for example, are running on virtual machine on some cloud. And it's able to let the user, the client, access grid storage, cloud storage, and in the case of grid storage, to handle for authentication, we use an external service that's a certificate token server that provides proxy for accessing grid storage. Because for grid storage, you need to use X509 digital certificate or proxy. All operations are tracked, so if there is some bad behavior from the user, you will know which user, which kind of resources has accessed and at what time. So the authentication system is very simple. To every request, it's needed a token. To obtain a token, you just need a couple of username and password. So the system provides a REST API to log in and a REST API to create a user. Once you log in to the service, you get back a token. Every time you have to send a request to any of the API of GLibrary, you just pass the authorization with the token. So like this in the curl example, here we are trying to browse for a repository, just pass the token. For the authorization, we have implemented access control list. With permission, we have reading, creation, editing, replica download, replica upload, both for repositories and collections. Where we can install GLibrary. GLibrary can be installed anywhere. Can be installed on Windows, on Linux, on Mac OS, on Raspberry, probably also on mobile phones. It just requires an installation of Node.js and a local or remote MongoDB. So everywhere you can have access to a Node.js system and MongoDB, you can run GLibrary. All the source code is available on GitHub. It's open source. And if you want to install GLibrary on your own server, please use branch test v2.1. We are still in a beta test phase, so commits are going every day. All this selection can be found also on the provided link if you want to install it, but it's quite easy. It can be installed in 10 minutes. Or if you want to give a try to GLibrary, you can use our installation, local installation in Catania at that address on port 3500. So now that we have a local GLibrary instance or using our server, how can we access GLibrary REST APIs? So we have a lot of options. Command line, so curl, wget, that you can integrate, for example, in your own script that run on worker nodes on your virtual machines. If you want to integrate in a web application, use the XML HTTP request or some wrapper of that, like jQuery Ajax or any library, that JavaScript library that is able to make in Ajax core. You can integrate in any portal, Liferay, WordPress. We have example of integration with Liferay. Or any mobile apps. All the major SDK, Android SDK, iOS SDK, Windows Phone provide HTTP clients. From desktop application, from set-top box. So being REST APIs, you can really access those services from everywhere. Of course, you need to have a JSON parser too. These are the only two requirements. GLibrary 2.0 has been written in JavaScript, as you have imagined, and using Node.js. Actually, it's based on a well-known framework. It's called Loopback that was recently acquired by IBM. And we use also MongoDB to store all the configuration, the mapping between collection and database, and replicas, and so on. For that access, we use this library, Juggler, that is an ORM, an object relational model, that is able to provide a transparent interface to several different backends. So we have tested with MySQL, with Postgres, and with MongoDB. But Juggler provides adapter for SQLite, Oracle, SQL Server, DynamoDB, CouchDB, and so on. Some history. GLibrary 1.0 was born in 2007, I guess. And it's a totally different idea than GLibrary 2.0, because GLibrary, and the name stands, the G stands for grid, was a really simple and easy to use system to store, upload, browsing, organize digital assets. So on grid infrastructure. So it was designed for grid. It was built in Python, PHP. It used AMGA as a metadata service that was developed during EGI projects, and collections at fixed schema, and the grid-only storage, and the API were not so RESTy. So GLibrary 2.0 is an evolution of GLibrary 1.0. We still have GLibrary 1.0 endpoints, and we still have applications that use GLibrary 1.0. It has been written from scratch. Just a second. Actually, from two persons. Me, I'm the software architect of GLibrary, and a colleague of mine that is not here. It has been rewritten in 4 months. Can do anything that can be done in GLibrary 1.0 plus more. Support many storage backends, and it's allowed the creation on demand of a new repository and of a new collection. While GLibrary 1.0, there was the need of the administrator to create a repository and a collection in advance. So here you can find all the reference for GLibrary, especially for the GLibrary 2 documentation. Please, if you look on the internet for documentation, be sure you are accessing GLibrary 2.0 documentation, not the old one, the source code. And here I've prepared a tutorial for you that actually I will run live after this presentation to show some of the REST APIs of GLibrary. If you want to contact someone for ask for support, you can contact me, or Roberto, or Antonio Di Mariano, who is the lead developer of the platform. Okay? Thank you.
Now,
questions?
questions?
Yes. Are there any questions?
Yeah, what does the G stand for now?
G.
Global.
Great.
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 Okay. I think we should take a vote.
All right. Yes.
Do you support transactions?
I think yes. I think so, because I have to double check. I remember that Zagger it should support transactions. So I will verify and let you know. I mean, because
Okay.
it's atomic operation in a single REST API. What happens then on the database is part of the Jagger drive. We did access directly.
Okay, yeah, I think then depends on database engine if it supports. Okay, and another question is what are output formats supported by GIL? So JSON, no HTML, or so? Yeah, I will get just JSON data and then I can do whatever I like. Okay.
That's the idea. It's simpler format. You can transform it XML, HTTP, and any format you like. But in principle, we could also add other transformers for output. To be
Is it supported by GLibrary to add these formats, or so can I create somehow my transformer?
we have to double check, because if you want to check that, have a look to Loopback, because we used Loopback as the framework that we built on top of it. And probably some other frameworks in Java, if I remember, you just need to change a parameter and say the output is JSON or the output is XML. I'm not sure, because we actually developed this system according to the requirements from the community. So, for example, if you have this kind of requirements, just ask us. We can dig it, and probably we can implement quite easily. Okay? At the moment, there's a knowledge. That's the answer to the question.
People watching. Well, hundreds of thousands of people out there.
You may have covered this, Tony, but when we were working earlier on in the year, this question came up. So at the moment, to log in, to get your credential, to get the token, you need to have username and password. Did you talk about whether this authentication method is going to change in the future, whether it can be done in a different way, or is it always going to be username and password?
That's what we have at the moment, but we can change the way you get the token, because the point is to let you give back a token. So if you want to use a certificate and change for a token, we can do that. It's the same answer. If there are needs for having this kind of feature, we can add it quite easily.
Yeah. No, I'm just thinking about having agents do things on your behalf and delegating the rights to them. So are they
You can give them a token. A token, for example, expires in 24 hours. Maybe you can create a longer token, so you can prepare a web interface from where you submit the agents, and you pass to the agents just the token. So even if the token expires, or if someone got the token, you can expire the token and nothing happens. So it's the same idea of proxy. Token can be thought as proxy. All right? More questions, or we do a break?
No, we
No break.
we swap.
We
We
swap.
swap. So now we need to shoot you on your back because you are gonna make the answer, right? The
Yes,
practical.
but can I have a drink?
Yes.
Not whiskey, I mean,
But
just
yeah,
water.
but 2 minutes because we cannot break and we cannot break for long. We are already late. So if you need to take a bottle of water,
Yes,
please.
that's it.
Okay,
That's it.
go. And we will. Run. By the way, if you want to follow this on the agenda page of the Hackfest, there's a link to this tutorial. If you look at the Antonio's presentation, next to his presentation there are slides already and the link to this tutorial. In the meantime, I have an announcement for you. So tomorrow will be the day where use cases will be presented, okay? So within today, close of business today, you should send me the title of your presentation and the name of the speaker or the speakers who will be talking, okay? And I will quickly make the agenda for tomorrow. If you have seen on the Indico page and the agenda page, tomorrow is empty yet. So by this evening, send to this address actually. Send me your presentation. If it is too big, just put on the cloud and send me the link, okay? Do it by this afternoon, and I will arrange the agenda, the detailed agenda for tomorrow. Yeah, I need the you send me the PowerPoint. If the PowerPoint is bigger than 5 megabytes, just put on a cloud or Dropbox, Google Drive, and send me the link. Okay, and I will put in the slide. I would appreciate if you can send me just a few lines. You have seen on the agenda, each talk has a short description, just an abstract. Send me by email.
Can I please suggest an alternative strategy?
Yeah.
So this suggestion of describing quickly the use case, why don't we start that as a topic on the forum and we can discuss
Yes,
it?
we can do on the forum as well, but I need something for the agenda page. So you can put on the forum, you're welcome to put on the forum, and I will copy paste in the agenda. Okay?
Yeah, because I mean, if people send an
Yeah, sure. But I need, or you just put if you prefer to put on a topic on the forum, I will look at the forum and I will download your presentation from the forum, or if you put a link from the link that you will put on the forum. But I need this by the mid-afternoon, late afternoon, because I need to build the agenda for tomorrow. Somebody already asked, if somebody's leaving tomorrow and you prefer to be in the first part of the agenda, because maybe you have a flight to catch in the afternoon, let me know, okay? Otherwise, I will just follow the arrival,
Devo
the
scrivere il
arrival
microfono qua. Devo salire il
date, the
microfono.
arrival date of
Ok,
the
sì, sì,
arrival
te lo devi
time
mettere.
of the email. Okay.
Se lo deve mettere.
No, non ti preoccupare.
That said, we can go on with the practical. Tony, no more than 15 minutes. Be quick, no more than 15 minutes, okay?
Ah, io ho un'ora di pratica.
20 minutes.
Vabbè.
Be
vado
quick.
veloce.
Otherwise, I mean, people can run by themselves, right?
Yes.
Okay, so just to see how they can do that, and because we need to catch up on time.
Ok, sì. Allora,
Saltiamo qua.
così mettere più vicino.
Posso iniziare? O dimmi tu.
Aspetta, te lo dico io quando, aspetta un attimo di pazienza. Aspettate che non ti sposti molto con la sedia perché c'ho il treppiedi messo.
Is the font big enough or
Make it bigger, please.
Make it, okay.
Per me può andare, eh? Lo metti grande o così? Lascio. Vabbè.
okay? So, if you go to github.com/csgf-glibrary, in the docs subfolder, I've prepared a tutorial, this tutorial MD files. You can also reach it from the agenda webpage. So actually, we are going to create first a user, login the user. Then we try to browse all the repositories on GLibrary. We create a repository, and this should be done by the administrator of GLibrary. We set SEL, and we create collection, items, and so on. So let's start by doing the first step, creating a user. So we're going to use CURL to handle with the REST API, but also I use Postman. I don't know if you know, it's a quite easy to use system to make examples, and the REST API, you can change the verbs, you can set headers, you can, let's say, change the body type, and so on. It's quite easy to work and test with REST API. So first of all, we are going to create a demo repository. Inside this demo repository, we are going to put some collection, and into this collection, we will put data from external MySQL database, or we use a local MongoDB database. So the first operation is to, of course, to create a user. So I will just copy and paste from here, and here I'm going to create a user that we call, okay, I have to change because I already used demo user. So I will call demo user 2. As you can see, we run this call against V2 users. I have a tool installed on my machine that is called JSON, that is able to parse the outputs and pre-formatting it. All right, so I get an error because it said emails already exist. That's why I used the same user yesterday. So I have to change also its email to demo user 2. Okay, so we have created a demo user 2. All right. So if you want to log in the user, we need to use the login API and pass the username and the password. So we do that.
Put demo user 2, right?
Yes. Demo user 2. pipe JSON. And here we get the information about the login. The most important thing, of course, is this. This is the token. Through this token, we can run all the following APIs. So working from the command line, it's a good tip to save this token in an environment variable. So I export the token, and I will save it. So the next time I will need it, I just refer the variable. Okay? So now we have a token. We can work with the G library. Actually, if we try to use the token, for example, here to browse, because we have this repos that is the endpoint for all the repository, with the token, we get this. Oh, sorry, let me put JSON so we can pre-font something. Yes, authorization required. That's why the user has not rights to browse all the repositories. Only the administrator can do that. So we need first to log in also as administrator and to create a new repository. And the new repository should be assigned to the demo user too. So at the moment, we don't have in our server a way to do through a web page. You just need to send an email to us. If you need, for example, an account, you just send an email there is the reference here where you need to send an email. And we will create a repository for you. Yeah, you need to send an email to sg.license, ctnfn.it, with your username, so you create the user, and the repository name. So let me, 1 second, create a token with administrative rights. I've already admin login. Okay, don't read the password, please. Too late. All right. So I have here my administrator token. So now everyone is deleting our repositories. Let me save this admin token. So I have both the token and the admin token. With this token, I can make administration request. So if I try again the call that I've done before, and I replace token with admin token, now I get the list of all the repositories that we have already in the server. Grid core, box, Fanny, Lezioni, Daria is there for projects that we're working on. So we see some of these other properties here. So, okay, now we have the admin token. Let's create now a new repository that we want to assign to our demo user user. Let me go back to my slides, repository creation. Okay, so as I've said, we use the REST principle. So we need to create something, we do a post. So what we do here is creating a post on the repos endpoint, and we pass the name of the new repositories. So let's change the name of these to let's call demo 2. So post on the repos endpoint. Here we go. So we have now a demo 2 repositories created. Now it's time to assign an access control list to this repository for the demo user 2. Currently, only the administrator can access that mount point, that endpoint. So we need to set up an ACL for the repository. Again, here we use the payload saying username demo user 2, and we give to the demo user 2 read and write permission. To the repos, we need to change the endpoint, that's repo 2, and underscore ACLS. So we are writing a new ACLS on this. Okay, so notice that we are still using the admin token and not the. Let's try. All right, the ACL has been added. So now we can switch token and we can try to browse this demo2 new repository. So we use a get. All right, you get an empty array because there is nothing, there is no collection into this repository. Let's create a collection. Now we can still work with the user token because the user is the admin of its own repository. And as I said in the slides, we can create a schemaless collection or a fixed schema collection or using data from a remote repository. We will do the first and the third because the time is not enough. Let's create a schemaless collection. So we just need to make a post, this time into the repository. It's demo2 with the name of the collection that you want to create. We want to create a movies collection into the demo2 repository. All right, the collection has been created and the ACL access control list has been added to the movies collection. So if we do again the browse of the repository in the demo repository, we see now that we have a collection and its path is v2 repos demo2 movies. Very easy. Now it's time to populate the collection with items. So I've created here some content. Suppose that this collection should contain data for a movie. I like a movie that's called Anger Management. I don't know if you have seen it with Jack Nicholson and Adam Sandler. If you haven't seen it, watch it. It's very funny. So let's change the destination repository. Every time I edit, because the exercise has been done with demo 2016, while here I'm using the demo 2. So what I do is just doing, again, a post, because I'm creating a new entry into repos demo 2 movies and passing the payload. Because this is a schemaless collection, I can create any document I want with any schema I want, and the document can have different schema. They are not to be of the same type. So let's run the call. Okay. So let's verify that with doing again browse. So we are browsing demo 2 and we see the movies, but we need to browse into movies. Okay, so this means get me back all the movies inside this collection. And here we have just this collection. Let me add some more, the same entries, 2 or 3 times. And now let's browse it back. Okay, so here we have 5 or 6 records. Of course, every item has an ID, like this one. It's auto-generated. Every time you make a post, a new ID is generated for you. But you see that you can also use the primary key of your database as ID. So if you want to access just this item, again, following the REST principle to individuate the resource, just put the name of the repos, the name of the collection, the name of the item, and you get back only that item. You can also delete an item, issuing a delete, edit an item using put. I'm not going to show all this because are quite easy to do. Now, let me show, for example, how to create a collection with a fixed schema, because you want that your user or your application need to create records or items that have always the same fields. When you create a collection, you add an extra properties called schema, where you describe the name of the attributes and the type. For example, here we are creating an actors collection that are 3 attributes: name of string types, date of birth of date type, and movies. And notice here we are doing something new. This time we don't want to store those items on the local MongoDB database that we have installed through GLibrary, but we have another database called Jular3grid.it. We need to provide the credential to this database. Again, forget this password after this presentation. Anyway, there are firewalls, so you won't be able to access them. So don't lose time to try. And now, let me 1 second delete these actors because I already have here. This is my control panel for my SQL database. I should have, okay, I can use another database demo. Let me delete the table, otherwise the demo won't work. So here I have my SQL database on a remote server, and I already created a demo database inside it. So this call will create a new collection and create a new table. Okay. Okay. So again, let's run this in demo 2. So we are going to create actors, and actors will be the name also of the collection. Okay, let's check what happens in the SQL database. As you have seen, it has been created a new tables that is formatted by the name of the repository demo2 plus the name of the collection that we have created. If you inspect the schema, it just does the schema that we described here in our JSON request. We can also add an entry, but we skip this. It's the same because we already have done that. It doesn't change anything from schemaless or with schema. It's just the same API we post into our collection. But now let's do something more interesting. So suppose you have already a database, and here I have a database called classical models. It's a database that is distributed with MySQL tutorial. It has several tables like products, like product lines. It's a database of classical cars, model cars. So suppose that you want to create a collection that let you access through REST API this table. So you want to create a REST API over the product tables in the classical database, classical model database, on a remote MySQL server. And GLibrary can do that. What you need to do is, again, create a new collection. You give the collection a name. We choose products, but you can, in principle, choose any name you like. And you use this flag, import true. Actually, it doesn't import data. It just provides access to the remote database. So it makes queries to the remote database and retrieve back data in JSON format to the user. Here you say what is the target table name and what is the collection DB that you use. So the database, the type of the database, we can use Postgres, you can use MongoSQL, the name of the database, the username and the password. And again, you need to do a post on the repository you want to create the collection to. So let me copy this. All right, it said collection and SCL created. So this means now that we can try to browse and see what happens. So we should have our demo 2. Into demo 2 now we have 3 collections. Movies is a collection stored in the MongoDB database. Actors is a remote collection stored in Joomla database. And products is the collection with data coming from the MySQL database. All right, as you have seen, you have all the records from the MySQL database into JSON format. Let me show now the query language I was talking to you before. So for example, you can use the filter parameter with some options. For example, limit, skip, limit just 3 records and skip 10 records. Or if you want to order items by quantity in stock, let's try one of this. So demo 2, products. You can do that. So here you see 9997 and so on. It's order in ascending order, but you can change also in the ascending order. You can, for example, make using comparison operator like where the buy price is greater than 90, or the price is between 60 and 50. So as you can see here, using the square brackets and where and the operator, you can make complex queries. Here you can use the AND operator. You say where both the buy price is greater than 50 and the quantity in stock is greater than 8,000. Finally, you can also use the like operator. So here, let's say I want all the product name where that contains the word Mercedes. So use the like operator like you used in the MySQL, and you pass the percent as a wildchar. All right, let's do the last call. I want to show how to create replicas, and I'm done with this demonstration. So for example, we have this car, the S18. Let me retrieve it. So products slash what's missing here? Products slash. All right. Notice here that the primary key of this table has become the ID, the item ID of the resources. So suppose that we want to attach an image, a JPEG image of this car. I've already. Let me find an image on Google. of a Mercedes-Benz 500 Special Roadster. All right, let's choose one of those. This can be nice. Let me store it in my home, Mercedes.jpg. All right. So to create a replica, we need to run 3 steps. The first thing is to create a replica entries in our for our item. The second step is to create a temporary URL where we actually upload the file. And the third step will be to do the real upload using the put commands. So let's do the 3 steps. The first step is to say we want to create a replica and we want to store it on a Swift cloud storage at this URI. Currently, here we are using the full URI of the Swift endpoint, but in principle, what generally is done is that the administrator of the repository will put a default endpoint, so you don't need to know where the file should be uploaded. So here I'm saying, okay, let's create a replica URI. What I made wrong. I think that I have sometimes it's better to create through, let me use post. So I want to make a post with the token. All right, headers. Authorization, and I will do the post on this URL, and the body, maybe there is I have some parsing problem. Swift Mercedes 2. All right, it works. So here we have the ID of the replica. That's what I needed to run the second step that used puts and asking for a temp URL for the upload. So URI is this one, okay, and the demo repo. Okay, I have 30 seconds to do the upload. Otherwise, the URL will expire. So I have to do curl minus t and the URL. All right, no errors. This is good. So the upload started. I was between the 30 seconds because the temporal will expire. And now let's try to retrieve the actual replica. So you just need to do a get on the item, no? So let's do from scratch. So we use the token. And we use the endpoint. So GLibrary v2 / repos / demo2 / products / the ID of the item that was the model of our car, then underscore replicas. I don't remember what was the ID of the replica, so let me print out just the replica ID was this one. So let me add the replica ID at the end. All right. Now we have 30 seconds to download this file. It's another temporal for get permission. If I go to a new web page and I put this, let me see, some file has been downloading. It seems it's the right one. Yes, we actually download the files without using any Swift credential back in our machine with just a simple URL. The last thing I want to show you is a web application that we are working on those days for the DARIA projects, where we use GLibrary API to make a repository on lemmas of the Bavarian dialects. At the moment, I have a demo running here. Let's see if the network, here the network is quite slow, but I think I can now stop the VPN. Probably the VPN Is there some network problem? Let me see if we have still network. Okay, if we didn't reach Google, this can be a problem, but maybe I can use my, no. We are ready to any problem. So GLibrary / DARIA. Meanwhile, I'm preparing the hotspot on my iPhone. We need always to have a backup solution in a situation like this.
Aspetta che io questo qua lo riprendo, aspetta che ho dovuto cambiare la scheda. Col telefonino questo è?
No, il problema è che non abbiamo rete.
Ah, vabbè,
e quindi
no,
mi
pensavo
attacco
che
al
era
telefonino.
col telefonino fatto apposta, vabbè.
Non funziona. Quale uso? Hackfest è più veloce, è più forte? Ma io non mi carica nessuno. Cambio un attimino. Ha funzionato fino ad ora. Riprovo con la VPN. Sorry, it was just the last minutes of demo. Murphy wasn't arrived till now, but he's arrived at the end, but we will kill him. I already... Okay, the network, that's horrible. Mine, maybe in my laptop. All right, I have Antonio's iPhone that will save me. Let me see the password. Again, let me change it. You already know it, right? People 1234, no? Casomai questo pezzino lo tagliamo e poi glielo aggiungiamo appena funziona. Ok, let's see. All right. All right, thank you H3G, writing network. So here the Austrian Academy has provided me with a database with several lemmas. It's all in German. I'm sorry, I don't speak German, so I don't really know. It's like 20,000 items. And here I'm using a framework that under the hoods makes queries. So I've implemented here an infinite scroll. So every time I scroll down, it's hitching queries to the REST API of GLibrary. GLibrary will access a remote MySQL database and transform this. So for example, if you want to look for item of author Hegel, I can apply filter, Hegel, no, Eugen. Yes, Eugen. And then I see want something that starts by material. Okay, so I filtered down from 20,000 entries to just 10 using the REST API of GLibrary under the hood. So now I can access some of those, and some of those as replicas. And here, for example, I can have a look to some files. Empty networks works good. I should just get the, using the replicas features of the GLibrary, it will get back the replicas for the items I'm clicking for, all in a transparent way, all using the GLibrary API. So actually here is doing REST API, the same commands that we have seen just 2 minutes before. We can also even download the entries and see the some lemma, I don't know, ancient Bavarian dialects information that can be quite nice, I think, for people that do this kind of works. All right, I think I'm done with this demonstration. Thanks a lot for listening to me this morning, and I'm here in the following days. If you want more information about that, please don't hesitate to contact me. Okay? Ciao a tutti, bye bye. Thanks.
Thank you very much, Tony.
Welcome.
Questions for the practical? Yes. Mike.
Ah, sorry. I think I can go to the paths in the pitch.
Yeah. Okay, thank you.
Sweet. Sorry.
It's on. Yeah, all right. So, yeah, I just have a very quick question. When you are using GLibrary with a remote database, when you are querying information, does it do any sort of caching, or does it always go and fetch data, right? Okay. So it always goes and fetch data from the remote database?
Yes.
Okay.
You can actually GLibrary, if you want to make things quicker, you can install a local instance of GLibrary on the same machine where you have the database. So it makes faster. The nice thing is that you can have just one collection or one repository that is a front end for a different database. So you can mount a collection to a database that is in Tanzania, another database that is in Catania, another database that is in Rio de Janeiro. And the user doesn't need to know. And you can also even make relation between tables coming from different databases. I haven't the time to show you, but GLibrary also supports the relation figures, and you can set a foreign key in a table that match a primary key in another table coming from another database. So it provides the structure for many use cases that you want to implement. Okay? More questions? Más preguntas? Altre domande? In tedesco non lo so dire.
Okay, so thank you very much once again, Tony. And now we will switch and we will move to the first talk of the morning. That will be a four-hand presentation. Carla and me will present the programmatic interface, programmatic access to open access repositories. Vi faccio la prima parte? Ok,
Sì,
meglio
poi-
modello della presentazione. Ok, è l'ultima versione, giusto?
Sì,
Ok.
è caricata dalla gente.
Ok. Ah, I need my glasses. I need to wear the microphone as well.
Si è staccato, ma non so perché.
E
Bene.
Microsoft, ok. Ok. Ma non è che è stesso, non dobbiamo vedere sul schermo è stesso.
No, era partito, si era in modalità presentazione,
Ah.
ora non si vede più niente.
Allora che sta facendo?
Dobbiamo staccarlo un attimo.
Ok. Non possiamo uscire forzatamente da Word da PowerPoint.
Direi sì, ma perché giustamente si è emozionato.
Ok, meglio. Non riportare niente. Facciamolo ripartire. Ok, aspetta, lascio caricare tutto. Ok,
Ah, la prima
sì.
volta.
Ok. 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 This is on. So very quickly. So as I said, that this is where is it? Okay, sorry. This is a four-hands presentation. So I will introduce some definition and some context of the work we are doing in the context of the Sci-GaIA project. Then Carla will drive you through some pre-recorded and live interaction with the open access repository. And then I'll come back on the last point that we think is very important and is about giving authorship of research products. So, part one, some concepts and definitions. So usually open access repositories are powered by what we call digital asset management systems that are very complicated combination of software databases to ingestion, annotation, cataloging, storage, retrieval, and distribution of digital assets. Antonio already talked about what a digital asset is. It looks like there is a more precise definition. Digital asset, in essence, is anything that exists in a binary format and comes with a right of use. And digital assets, Antonio already showed this, include many different things. So photography, logos, illustrations, animations, audiovisual, media, presentations, spreadsheets, words and PDF documents, data. That is one of the important items we want to tackle in this Hackfest. When you look for DAMSs, there is a lot of possible choices. These are the most common DAMSs. There are other more social or business oriented that you can find in the link at the bottom of the presentation. In Sci-GaIA, we have a task on creation of federated and interoperable open access document and data repositories in Africa, compliant with European and other international guidelines. So on one of the activities of this task is to create promote the creation of open access repositories based on standards. So we had some stringent requirements. We wanted something open source, distributed under a free license, free, it would be more correct to say open license, deployable on a local infrastructure, so not an hosted service. Some of the demonstrations I showed before are hosted. Standard compliant, well supported, and scalable. The choice was Imenio, the latest stable version, plus a series of add-ons that we added to Imenio. The motivations were manifold, fully compliant with all most important library standards, Dublin Core, Mark 21, OAI, PMH, is developed at CERN with co-developed with many other laboratories in the world, and there are very important repositories like Inspire for energy physics, SCOPE3 for published energy physics papers, and Zenodo, that is the flagship archive of OpenAir, that are based on Imenio. So we are building on a technology that is actually widely used. Concerning scalability, the CERN document server operates since almost 15 years and currently manages more than 1.3 million documents. So it's the right scale we wanted to have at the beginning. And it looks like UNESCO and the UMLE, so MOA, an association of West African countries, have a project to deploy virtual libraries based on Imenio in different countries, and the countries are listed there. So I think that there was a very good choice. So that's Imenio. That's Imenio skinned for Sci-GaIA. Important thing, we enabled federated access. So using the same credentials you got yesterday to access the forum, this course, if you go to that URL, you can log in and you can start uploading your research products. The resources can be manually uploaded. Carla will show you an example, or can be automatically harvested and ingested for external sources. The problem is that with GLibrary you have seen something to easily work with distributed database. But now the problem is that we have a problem of visibility of research products. So we can automatically harvest products from invisible databases and make them visible through Imenio. More than visible, because you will see later, we assign digital object identifiers to each of the records of the repository. So you can even assemble different resources in what we call research packages. What we have added to Imenio is the possibility to mint the DataCite digital object identifiers and assign them to the records. Direct link to the alt metrics. So if you publish the records, if you publish research products on Imenio, you can cite on social networks, and they will be acknowledged automatically, more quickly than normal citations. And we adjusted the correct metadata, the Dublin Core metadata, so that the OAI PMH endpoint publishes data that are compliant with the version 3.0 of the OpenAir guidelines. So all the open access repositories built with Imenio could eventually become official OpenAir repositories. We are still about compliance with standards. The repository is fully conforming with OAI standards, and we are one of the records of the OAI list of repositories. And we are also compliant with Open Door, which is a worldwide initiative on open access data repositories, and our repository is one of the data providers of Open Door. But what we want to do with the open access repository is to enable the knowledge workflow. You may remember from my yesterday's presentation, we want to connect open access repositories to Science Gateway so that you can browse if you find a document and the document has all the elements, data, workflows, software, even container or virtual machine, you can automatically be redirected to the Science Gateway and rerun your application or the data and publish it in a given paper and reuse them for further analysis. This has been done, has been demonstrated, and we can provide you examples on the Science Gateway for those interested in developing Science Gateways. I've been talking about DOIs. DOIs, so each record has a DOI, and the records can be combined together in what we call research packages. So you can see here, this is an analysis. This is not the first one, is a fake object. It's not linked to any paper, but it's just an analysis. So if you click on this, you are automatically redirected to the Science Gateway where this analysis with those data and using that virtual machine can be redone. The same for another infection model based on RePast, is an agent-based analysis. You have the research package containing everything you need to rerun the analysis. So you have the virtual machine, you have the graphic visualization tools, and you have all the data. So all the DOIs can be assembled in a research product, and a research product is all you need to reproduce that particular result. And we also have a completely different thing. These are the 3D CAD files to print parts of a weather station with the 3D printers. There is a project aiming at deploying weather stations in Tanzania, Kenya, and Uganda. They are building 3D printable models, and so we have a research package containing all you need to 3D print these weather stations. The OER itself is a research package. This was just a demonstrative open access repository, but you have the guidelines, you have the instructions, and you have the virtual appliance. So if you go to this record, you have the virtual appliance containing a clone of this open access repository. And actually, there are 6 clones being deployed in Africa and in Europe. So you can go to the open access repository, download the virtual machine, download the guidelines, download the instructions, and you can create a clone. So you can just you can easily use in-menu documentation to configure it. You attach your DOI subprefix, and you are done. So whatever is possible with this demonstrative repository, you can do with your own. So that's the idea. So I think I'm teasing you enough, and I will give the floor to Carla, who will show you how to actually interact with the open access repository. Keep in mind that all the interactions Carla will do with our repository, you will be able to do with your own clone if you install at your premises. Okay, so Carla. Okay.
Quando ti serve switchare?
Ora.
Ora?
Sì.
Okay, so it's we need to change again and record what Carla will do on the screen. We need to shoot on Carla behind, because part 2 we have the slides, but whatever is in the slides, Carla will play live. So we need to put the camera here.
Ah, vabbè.
Okay? So you have the slides as reference, but Carla will do whatever is in the slide live, right?
Yes.
Okay.
Now it's live.
Yes, ok. Now, dobbiamo riprenderti da dietro.
Ok.
Aspetta un secondo. Ok?
Non gesticolare.
Perché sennò non
Certo,
si
certo.
vede.
Se torna alle slide,
Io devo-
resta qua, resta con la camera qua.
Ok, quindi
Tanto le slide ce le abbiamo.
posso ritornare
Sì,
alle slide.
Sì.
microfono se l'ha messo? Sì, ok. Per me va bene.
Let's start. Hi everybody. Now in this part of presentation we're starting to view how we can submit a new resource using the interface, web interface of Sci-GaIA Open Access repository.
A little bit bigger, just the font. One click, okay.
Okay. And to do this, first of all, you have to log in the system with your federated authentication. And now you can submit a new record clicking on Submit tab, and the system show you a list of type of documents that you can upload in the portal. In this case, we will upload a presentation, the presentation of programmatic interaction. After that, you can, the system retrieve to you a list of radio buttons that represent the category that you can assign to your resource. In our case, we will use the Demo Hackfest category. After that, we can click on Submit New Record. Here is the submit form. You have to fill the information of your new resource from this form. There are many types of files. Some are mandatory and some are optional. And for example, the first file is mandatory, and this is the digital object identifier. If the resource that you are uploading has already a DOI, you have to copy it in this text box. Otherwise, you have to click on Reserve a DOI, and the system provides you a new DOI and assign it to your new resource. You can select the type of the resource that you are uploading. In our case, we upload a presentation. Here you have to insert the title of the resource. In our case, it's programmatic interaction with open data. Here you have to insert the authors of your resource. If the resource has one or more authors, you have to insert one author per line. And in the first line, you have to insert the main author of this resource. In our case, the main author is in the last line, me. Here you have to insert the abstract of the resource. To do it quickly, I copy it from the agenda. This is an optional file. The number of pages is an optional file. A mandatory file is the language of the resource, in our case English. Here you have to insert the date of the resource. And we insert day, month, year format. Here you can insert the keyword, the key phrases that you want to assign to your new resource. In our case, for example, we can assign the Summer Hackfest and repository, or open data, for example, Sci-GaIA, and each keywords and each key phrases you have to insert one per line. You can insert additional notes or comment or to assign to your resource. Important file is the license. In our case, you can select a license of the list. In our case, we use the Creative Commons Attribution 4.0. Here you can insert the EU project. You can find more projects, for example, Indigo. And the system retrieves the complete name of project, but in our case, we will use the Sci-GaIA EU project. Here, if your resource has already reference, you can insert one per line the reference of the resource, inserting the DOI of the resource, the main author of the resource, and the title. After that, you can click on Browse button, and you can upload the presentation. If all okay, you can click on Finish Submission, and you send the upload request to the administrator. Yes. And the administrator get the request, and in a few minutes you can retrieve. You can retrieve the information. For example, you can find your new resource under the collection presentation under the Summer Hackfest. This is an example of uploaded resource where if you want, you show all information, the title, the editors, the DOI, and so on. I start with presentation. I return in the presentation. In the same way, you can upload a new image. You have to select the Demo Hackfest category, and after that, you have to fill all information inside this form. The DOI, the title, the editors, the description of the image, and clicking on Browse button, you can upload the file that you want to upload. And in the same way, you can upload a new audio-video recording, selecting the category Demo Hackfest. This is the form that you have to fill. You have to insert the DOI. If the resource has already one, you have to insert it. Otherwise, you have to click on Reserva DOI. You have to insert the editors, the title, the description, and so on. Clicking on Upload Video, you can select the video that you want to upload, and this operation will take more of a few minutes. Be patient. And if all okay, you can click on Finish Submission, and the request is sent to the administrator. And in a few minutes, even about in 24 hours, you can retrieve the new video from the repository. Now we are going to view how we can interact with the open access repository using the search engine API. There are three kinds of API that you can use: the XML API, the JSON API, and the Python API. About the XML API, this is the syntax. You have to use a base URL and a syntax like this with param and value, a list with param and value. An example of XML API is, for example, get the first and record in XML format. To do this, we have to use this request, where we use the JREC param that stands for jump to record. For example, the one for the first hit. RG record stands for records in group of, and for example, 10 hits per page. And the param OF stands for output format. And in our case, is XM format to retrieve the output in XML format. And if you set the GREC param and the RG param appropriately, you can paginate the output. For example, using this request, you get the first param, the first 10 param of the repository. If you use this query, you get the second 10 param of the repository, starting from the record number 11, JREC 11. In the same way, you can get the third 10 record of the repository using this request, where JREC param is equals to 22. If you don't set the RG param by default is set to the highest value, and in more of case, this value is 10. An example of query, another example of a query is get the first record that contains the string Sci-GaIA Winter School in the title. To do this, we have to use the first request, where you have to use two params that are the P params that is the pattern, is the query that you want to do, the string that you want to search. You must use file to that stands for file to search within, and you specify using this param where you are searching the string. Another type of query is this. You can get a record, a specific record, using given DOI. If you have the DOI, you can use it to retrieve all information about this resource. To do this, you have to use this request, where you use the p param, and the value of the p param is DOI colon the DOI of the resource that you are searching. Another type of query can be get all records uploaded from a given data to another given data. To do this, you have to use the param D1 and D2 that are the first date and the second date in year, month, day format. This is an example of query that retrieves the information in XML format. The XML format covers the mark XML tag. If you want to use the JSON output, the JSON API, you have to set the OF param on RecJSON value. If you want to use the JSON API, you can use all the parameters that you can use with the XML API. This is an example of query that you can do with the JSON format. This is the same. This is the same of the first of the query that we have to with XML API. The difference stands on OF value is RecJSON. In the same way, you can get the all records uploaded from a given data to another given data using D1 and D2 param, and OF equals to RecJSON. This is an example of output in JSON format. You can use the name of the param, for example, abstract, creation date, keyword, to do the to filtering the result of the query. For example, you can use this. You can get only the abstract, the title, and the authors of a resource using a new param that is OT, that stands for output tags. In this case, the system retrieves to you, show to you only the abstract, the title, the authors of each resource. Now, the Invenio search engine can be called from within your Python programs, and you can use all the same param that we use for XML API and JSON API. If you want to know more about the param that you can use, you can visit this GUID. Now we are going to view how you can download one or more records. If you want to download records, you need the public key and private key that are provided by the system. And you need of a signature that you have to calculate. How? You have to write your query that must contain the API key with the value of your public key and pass it with the private key to the HMIAC method that produce like output the signature. If you want to load one or more records, for example, from your script, you have to use this query that contains the API key and signature that you have just calculated. If you want now upload one or more records, you need to send an authorization request for your IP address to the administrator and create a mark.xml file as input. The mark.xml file, your file XML is more important because this file contains all records that you want to upload. And once you created the file and your IP is authorized, you can use this queue to upload the file. The administrator after accept the request. If you want to know more about the upload, you can visit this kit. But now we start to talk of your file XML. The file XML must support the mark format that is the standard in the library world. And your file must contain a tag collection. And the tag collection can contain one or more records. Each record represents a resource, the resource that you want to upload. And each record has more data file tag. Each data file tag represents a mark.xml tag. An example can be the tag 024, that is the tag that specifies the DOI of the resource. Another tag can be the 100 tag that specifies the main author of the resource. And here you can insert all the information of the author. For example, the subfile code E is the name of the author. The subfile code J is the orchid of the author. And this is an complete example of a record that you can upload inside the Sci-GaIA repository in Venue-based. Some of these tags are mandatory, others are optional. A mandatory tag can be the 024 tag that is the DOI identifier of the resource. Another tag mandatory is the 100 that is the first author of the resource. Some of these tags must be uniquely. So, for example, the main author, you can have in one record only one tag with the code 100. If your resource has more of one authors, you have to insert the other authors using the tag with code 700. So your records can have one or more tag 700, but only one tag 100. Other type of tags are, for example, the tag 653, that is the keyword tag. You can have in one record more of this tag. The tag, for example, 980 is a mandatory tag that is the collection of the resource, and you can have only one of this tag. If you want to know more about the old tag, you can use other tag, but this is an example, a complete example to upload a new record inside the Sci-GaIA. You can visit this GUID and read all information about each tag. Another way to interact with the Sci-GaIA repository is using the search engine based on OAI-PMH standard protocol. The Sci-GaIA is publicly available at the endpoint segment. You can use this endpoint to get, for example, detailed information about an available set of the repository. You can list, for example, all the records in Dublin format using this request. If you have OAI identifier, you can retrieve all information of a record using this request. And this is an example of output of request where the system shows you all information about the resource with a given OAI identifier and show you all the resource, all the Dublin core metadata of the resource. And
Okay, thank you very much. Thank you very much, Carla.
Thank you.
On this technical part, before I go back to, on to part 3.
Can you go back to where you specify the XML, please? Yeah, so this is specifying.
Wait. Back. Otherwise, nobody will listen to your great question.
Okay, so you're describing attributes of the object. Where do you describe the object? Like, where is the actual object in this XML? Yeah, where is it? Let's say I've got this object, and I want to describe it with this XML. So I write the XML, and I want to send this request XML and the object to have it ingested into. No, not in JSON. To ingest it. Yes. Okay, and I have to. Yeah, but that's the XML file.
Yes.
What about the actual object?
The data.
Yeah. Like, let's say I've got a PDF. I've got a PDF, which is my paper. Yeah, no, that's fine. So I have to construct the XML properly. That's fine. But now I've got my XML, which has been properly constructed, and I've got the actual paper or the data. Like, where do I describe that? Okay.
Let me help you. I will be a physical pointer.
Yes, please.
Wait. This.
Yes, it is.
This.
Okay. So, all right.
The PDF, you can insert the URL to the PDF here.
That's a local file, right?
Yep.
Yeah, yes.
Any other question? Okay, if not, thanks. Carla, can you put on part 3? And I
Yes.
will, now I get to sit without screwing up. Actually, I want to back. Okay. Yes. Okay, so now we have seen what you can do, and you upload data, you can upload papers, you can upload software, you can upload whatever is needed to create what I called before a research package. The problem is, once you do that, who's this science of? How can you ensure that what you upload is yours? How can be rewarded by what you uploaded on the open access repository? Because the object itself can be cited, you can get alt metrics, but how can you make your own science more visible? That's the problem. So since we are using the OIs, this comes basically for free, thanks to the interaction between DOIs and ORCID. So ORCID is becoming a de facto standard to disambiguate researchers in the world. So I may ask you, how many in the room have ORCID profiles? Well, is always, every time I ask this, is between 10 and 15% of the audience. That's really bad. But I mean, you can get an ORCID in minutes, and actually more than 2.2 million researchers in the world. Okay, great. Stick your orange post-it on your laptop. Okay. Okay, so ORCID is a non-profit organization. So you register your ORCID, and then you get a unique identifier that you can attach to your papers, to your data, to whatever you produce. So you have seen this already. In the OER, in the Sci-GaIA OER, we have a data site DOIs. And you can connect you can connect your research products, your publication, your data sets, your images, your figure, your reports to your ORCID profile using DOIs. So Carla showed you that when you upload something, you can assign a DOI. You can assign a DOI when you do that from the web interface, or you can do that using the API. So you have a beautiful final set of data. You upload on the open access repository, and you assign to each data set one DOI. And you can do that just running a script or behind a web portal using the APIs that Carla showed you. Then, Sci-GaIA has, thanks to the University of Catania, we provided to Sci-GaIA a prefix, a DOI prefix. So what are you going to do with the DOI prefix? So, okay, all records in the ORCID can be claimed. How? If you go to ORCID, you log in on your ORCID profile, you don't need to fill your papers one at a time. This would be very boring. But you can search and link from your papers on external sources. For example, if you already have your data on Crossref, on Researcher ID, or on Scopus, you can claim all of them. But one of the external sources you can claim your research product from is DataSite. So if you click on DataSite, then you are redirected to a page where you can put all your identities. So that's my ORCID. I sign papers under Roberto Barbera, or Barbera Roberto, or Barbera, or other kind of, and you know the way you sign, so you can put everything here. Then you get, you search, and you get something. You get a list of papers that fulfill the request. So basically your paper. And you can see that some of your paper are on the Sci-GaIA open access repository. You can be paper, dataset, reports, all the gray literature. The gold literature is what you publish on your journal, on your web journal. But if you have a DOI, still you can connect a paper you published on Physical Review or on Physical Review letters with the data you have published on your institutional repository. And together they can be combined as a research object. So you can just say, okay, I want to add to ORCID, and this will go into my research product, into my ORCID profile. Or I can say, okay, I can say to DataSite that every time I publish something and assign a DOI, it automatically put in my ORCID profile. So as a scientist, you will become very easily more visible, because you can connect not only your beautiful papers, but you can connect your internal reports, your deliverables, your data sets, your software, whatever. And you can do that starting from your application. You don't need to do that in the boring way, like filling a web form. Programs can do that for you. So behind Imenio, you can have a local storage, you can have a cloud storage. I know that people manage to assign one data storage, distributed one database storage to Imenio. But using Imenio, you can merge the concept of data repositories for file, digital libraries, where this was intended to be a kind of provocative presentation to try to merge completely different things. the idea of data repositories that are used by communities with libraries which are used by different communities. And then instead you can merge